Hello again, this is Susan Poss, and this is the last video from section 9.4. This is another binomial times binomials. We're going to use that first, outer, inner, last technique that you saw me use earlier. But before I do that, let me remind you of a simpler problem that does not contain a radical. Notice that the binomials are the same except for the sign in the center. So there's an x and a 5, an x and a 5. One's an x plus 5, the other's an x minus 5. And when you do FOIL on this, outer, inner, last, you remember how these two in the middle drop out, add up to 0, and you end up with this perfect square. No, sorry, it's not a perfect square. It's the difference of two squares. Sorry, that's what I meant to say. You end up with this expression called the difference of two squares. Right, so this is going to behave in the same way. So you're going to see me do first, outer, inner, and last. All right, so first times first, outer, inner, and last. So again, here are 1, 2, 3, 4 terms, just like I got 1, 2, 3, 4 terms over there. All right, so we learned earlier that the square root of something times the square root of that same something is that something that's under the radical. These two terms are alike. They both contain the radicand 2x with the same index 2. So what I'm going to do with these is there's going to be a negative 5 and a positive 5 here that are going to combine, and this 2x, square root of 2x, is going to just trail out there on the end. And there's the minus 25. All right, so you see, again, just as happened over there in the previous example from an earlier time in your math experience, this positive 5 and this negative 5 are going to add up to a 0 times the square root of 2x. Well, 0 times anything is 0. So you end up with 2x for the first term and minus 25 for the last term. Okay, that's the last exercise in section 9.4. Hope that helps.